Right, now we are looking at continuous data. Let's quickly go for it. Well, what is it? What is continuous data? Well, it is data that cannot take exact values. Okay? It is data like the mass of a person or the height of a person. Really, if you are to exactly know the height of a person, you might be surprised because you could have it being something like 1.25798631 meters. You could keep going. What only limits us is our unit, is our instruments that we use to measure the height. They round off. But height can keep going. Okay, it can be any value with even small things. So this is a type of data that really keeps going. Okay? It can be anything. That is continuous. You cannot limit it. So it cannot take exact values. It can be anything. Now, it is given only within a specified range. Okay? We can only give it within a specified range because it can be any value. So we say it can be any value within a certain range. We never really know the values, okay? But it could be anything. The height, the mass, those type of things. Not only that, but you could have something like time or speed, okay? It could be any value, okay? Now, here it is only within a specified range or to a specified degree of accuracy. It depends on the instrument you're using. So sometimes you'd be like, oh, it is 6 o'clock, when in fact it is not. It is 6. Maybe it could be like seconds past and milliseconds and microseconds. You know, it keeps going. Time can have seconds, seconds, milliseconds, microseconds, hours, minutes, all these other things. So anyway, continuous data usually arises from measuring. Okay, we saw that discrete arises from counting, but continuous data now arises from measuring, using whatever you're using. Measuring, you use an instrument. It could be a watch, it could be anything, a ruler, whatever you're measuring, depends on what you're measuring. For mass, it could be a scale. And these type of things that you measure are usually continuous. They are not discrete. Discrete, you count, you don't measure. Because once you measure, there is a degree of uncertainty. Okay, that means we never really know the answer, right? That means we can't give it an exact value. But then when you are counting, it'll be 1, 2, 3, 4, 5. Those are the counting numbers, right? Exactly. Now let's look at an example. The following data was obtained from a survey because what we want to know is how to make the frequency distribution. Because frequency distribution for this guy is the reason why we were doing those stupid tables. Because somebody will be like, why were we doing that stupid table we did in discrete where we were putting the frequency and the type of data? It's so easy. Okay, for here, you got to be a little bit careful, especially when we are now going to be applying the knowledge. Okay, right, let's go ahead. So